Welcome back to the flight deck. Today's explainer is all about surviving an engine failure, specifically mastering the practice forced landing. We're going to take what feels like an absolutely terrifying scenario and transform it into a highly structured, totally manageable sequence of events.
All right, picture this. You're cruising along at 3,000 feet, enjoying the view, and suddenly, silence. The prop stops, the controls feel heavy, your adrenaline instantly spikes. What do? Well, as your instructor, I'm right here to tell you exactly how we handle this. We're replacing that sudden panic with a precise step-by-step procedure.
So here is our pre-flight briefing for today's lesson. We'll break this down into 6 clear steps. First, what to do the second the engine quits, then pitching for best glide, running the immediate restart flow, picking your landing field, flying the key points, and finally managing the final approach and go around. Okay, step 1, the engine just quit, so you need to aviate first.
The absolute first priority when you realize you've lost power is maintaining control of the aircraft. Don't freeze up, and whatever you do, don't immediately grab the radio. Just fly the plane. Now, it's so easy to panic when that engine dies, but look at this number on the screen. 3 minutes. If you're at 2,000 feet above ground level with a typical 700 feet per minute descent rate, 3 minutes is exactly how much time you have. That is plenty of time to calmly run your checks. Honestly, 3 minutes in the cockpit is a really long time if you stay organized. So whatever you do, do not rush. Moving into section 2, pitch for best glide to maximize your time.
To guarantee you actually get those full 3 minutes we just talked about, you have to instantly establish your best glide airspeed. If you don't nail this speed, you are literally throwing away precious time and distance. Pitching for this exact speed is absolutely critical. Why? Because any error here rapidly steepens your descent and drastically reduces how far you can glide. Think about it. In a standard trainer, a 12-to-1 glide ratio means for every 1,000 feet you drop, you glide forward 12,000 feet. That's a massive distance. Once you hit that magical airspeed, reach down and use your trim wheel. Get the aircraft trimmed out so it naturally holds that speed all by itself. That frees up your hands, and honestly, your mental bandwidth, for the next crucial steps.
Now, to quickly visualize where you can actually reach, try this conservative rule of thumb. If you literally lower your arm about 10 degrees below the horizon, you should be pointing directly at a field you can safely reach without power, assuming zero wind. It's a fantastic, fast geometric trick to establish the boundaries of your options.
Okay, section 3, the immediate restart action flow. Let's see if we can get this engine running again.
With your speed locked in and the plane trimmed, you need to run through your muscle memory flow to wake this engine back up. You'll execute these 5 actions deliberately. Close the throttle, hit the fuel boost pump, change your fuel tanks, push the mixture full rich, and turn the carburetor heat hot. Doing these steps might just solve a simple fuel starvation or icing issue on the spot. You would honestly be shocked at how often a silent engine is just a forgotten fuel selector. If that propeller is still windmilling out there, fixing the underlying fuel or air problem will fire it right back up, no starter required. Which brings us to section 4, picking your landing field. It's time to find a safe runway. So what if the engine doesn't restart after your flow? Well, we pivot immediately. We switch our focus directly to navigation and field selection. You are basically flying a heavy glider now, and you need a place to put it down. Burn this mnemonic into your brain. Whoa, sass. It is your definitive go-to checklist for evaluating if a random patch of dirt is actually a safe runway. You're scanning for wind, hidden obstacles, like power lines, which are notoriously hard to spot, the size and shape of the field, the surface conditions, your over and undershoots, the blinding sun, and finally, civilization, just to make sure help is nearby once you're on the ground. Notice that the very first letter in that check is wind. It is absolutely vital. You should always be looking outside for environmental clues. Is there smoke from a factory, dust blowing across a road, or maybe wind lines on a pond? Spotting these is critical because landing into a headwind will significantly lower your touchdown speed and drastically shorten your landing roll. Touching down at 40 knots instead of 60 knots on rough terrain, yeah, that could literally be the difference between rolling to a smooth stop and flipping the plane completely over. All right, section 5, flying the key points to structure your descent. So you've picked your field, now we have to construct a traffic pattern out of thin air, using strict geometry. You simply cannot just guess your way down to the ground. Instead, we use what we call the high key at 2,500 feet and the low key at 1,500 feet right abeam your touchdown point. These act as invisible gates in the sky to structure our spiraling descent. They let us constantly assess our altitude.
By aiming for these specific gates, you turn what feels like a chaotic plunge into a totally predictable, measurable pattern. If you arrive at the high key too high, no problem. You know immediately to widen out your turns.
Once you hit that low key, you'll extend your downwind to set up a long base leg and a short final. This specific shape is a game changer. It gives you maximum flexibility to cut the corner early if you realize you're getting low, or to widen it out if you're coming in too high. Plus, a long base leg gives you an awesome view of the field from the side, which lets you really accurately judge your descent profile before you commit to that final turn.
Moving to Section 6, Final Approach and Go Around. This is the critical phase.
We are now entering the phase where the most common and dangerous student errors happen. If you find yourself low on final, human instinct is going to completely lie to you. The deadly wrong reaction is pitching the nose up to try and stretch the glide. Do not do it. Pitching up will bleed your airspeed and cause a stall. The correct reaction? Delay your flaps and simply accept a shorter landing. I honestly cannot stress this enough. Never, ever raise the nose to stretch a glide. You will literally drop like a rock.
So how do you actually control your descent point? Once you are absolutely 100% certain you're going to make the field, you progressively add flaps. Extending full flaps will safely steepen your approach and bring your aiming point closer to you, all without increasing your airspeed. Think of flaps as a tool you use to literally drag that aiming point exactly to where you want it.
Now, a very important note since we are training. The golden rule here is the minimum altitude during a practice forced landing is 500 feet AGL. When we're running this simulation, that 500-foot mark is our hard deck. You absolutely must execute a go-around by 500 feet above the ground to make sure we don't put the aircraft in actual danger. Remember, the practice is all about mastering the setup and honing your judgment, not actually putting the tires in the dirt.
But let's say this was a real emergency. Once your landing is totally assured and you are fully committed to the touchdown, you need to complete your safety checks. You want to secure the fuel and electrical systems to minimize any fire risk. Turn the fuel off, pull the mixture to idle cutoff, and kill the master and magneto switches. You want that aircraft to be as inert as physically possible when it finally meets the ground.
Always remember, an engine failure is really just an unplanned glide approach. If you stick to the strict structure we covered today, you will completely own the aircraft all the way down to the ground. Altitude buys time, and time buys calm decision-making. By memorizing your best glide speed, executing your memory flows, and flying the exact geometry of your key points, you take all the panic right out of the cockpit. So the only question left for you today is the one right here. When the props stop spinning, are you ready to fly the scenario?